Okay, welcome back, and this is going to be the solutions to the fifth AP Chemistry FRQ, and let's just go ahead and begin. You can access these FRQs in the official AP College Board PDF file, which I have linked in the description box down below, or you can put this link showing on your screen into your search bar to follow along. And just another reminder that this is not affiliated with the AP College Board in any way, shape, or form. This is just a video discussing over the answers to the FRQ. Okay, and with that out of the way, let's begin with question 5a, and this is asking us to determine the k value given a table with some values. So I'm just going to pop the table back on here for reference, and to solve for the rate constant, we can actually use the half-life equation. And this is actually given in your reference sheet, so you don't need to memorize it or anything. So it's going to be the T sub 1 half, or the time it takes for the concentration to decrease half its life, and that's going to equal 0.693 over K, which is the rate constant, and that's exactly what we're looking for. Now, if you look at the table, you'll notice that on the right-hand side, the 0.160 is double the 0.0800, and it keeps decreasing by half each time. So looking at this pattern, it is decreasing by half, and we'll actually be using this information later. So now we need to determine how long it takes for the concentration to decrease by half, and that will now be our T sub half. So looking here, each time it takes about 1.67 hours or so to make the concentration decrease by half. So this is now going to be your new T sub half. Now let's plug that into your T sub half part, and that's going to still equal the 0.693 over K. So now let's just solve for K, and if we do so, we get a 1.67K, which equals 0.096, and solving for K, we get a value of 0.415 as an answer. Now moving on to part 5b, we have some mechanisms, and we're asked to identify which one matches the rate law given. As a reminder, this was the rate law they gave at the beginning of the question, and now we have to find out which mechanisms are the same in terms of the rate law. It's first good to know what the rate determining step is. The rate determining step is going to be the slow step because it dictates the rate of the reaction. Think about it. Let's say you're doing a relay race and you're the last person to run. So you're going to be the last person, you're going to make it to the finish line, and that means that everything depends on you. If you run slow, then the entire group is only as fast as you can run. So if you run slow, then that will dictate the entire time it takes to finish that relay race. So, having that kind of example in mind, the slow step will always dictate the rate of the reaction. Now, because the rate law is given, that means we must come up with the rate determining step. So, given all of this, it must be step 1 because the rate law is the exact same. The rate law is just the rate constant, which is K, and the reaction concentration, so this perfectly matches up. Step 1 is the rate determining step, and therefore is the rate law. Now, last part, which is part 5c, we're asked to determine what will happen to K if we add in more concentration, assuming that there's no change in temperature. Now, this is a really interesting concept because remember that the only thing that affects the equilibrium constant is temperature. Now, why is that? Well, concentration or pressure doesn't matter. They don't matter in this case because even though it does temporarily change the constant, the system will eventually reestablish equilibrium by shifting forward or reverse to compensate for that change. In the end, the constant will be the same, but when you change temperature, this actually changes the number of collisions, and remember that K is the ratio of constant forward and reverse rates. When you change the temperature, this no longer becomes constant because of all the collisions happening, which makes the reaction either faster or slower. This isn't constant, so the K value will change with temperature. But in the problem, it says that the experiment was repeated with the same temperature. So will K actually change? And the answer is no. K will remain the same because temperature is not changed, and because the K value depends on temperature, the K value will stay constant. You can explain the reasoning using the collisions and what will happen to the equilibrium constant because of that. And that looks like the end of the FRQ. Here's some of my score predictions and what I think you might need to get in order to pass with a 3. And this is the score prediction for 4 or 5. And just a quick note that these are not the official score predictions like from AP College Board. These are my own guesses as to what it could be. And as always, thank you so much for watching. Hopefully you learned something new. Make sure to subscribe for more, give this video a thumbs up, and turn on post notifications to be notified whenever I post. Also, if you took the AP Language test this year and want to know the answers, make sure to click on the video to the left. And if you want to check out the AP Chemistry answers to FRQ number 4, press the video on the right. And I guess I'll see you guys next time. Bye!